By the end of this lesson, you should be able to determine the relationship between pressure and temperature at constant volume for a fixed mass of gas, that is, P over T equals to constant. A car is traveling 110 kilometers per hour on a highway for a distance of 200 kilometers. At the end of the journey, the driver noticed that the tires become stiff. What caused the tires to become stiff? The friction between the tire and the road caused the temperature of the tire to increase, and this caused the temperature of the gas inside the tire to rise. When the temperature of a gas rises, the average kinetic energy of the gas molecules increase, and the molecules move faster. Hence, the gas molecules strike the wall of the tire at a higher frequency with a larger momentum. That is, the force acting on the tire walls increases. As a result, the pressure of the tire increases when the gas temperature increases. Observe the simulation. Click and drag the slider to vary the temperature. When gas in an enclosed container of fixed volume is heated, what happens to the gas particles? When the temperature of the gas particles increases, they move faster, and the rate of collision of the particles with the walls of the container also increases. The force acting on the walls of the container, hence the pressure of the gas increases. What is the relationship between the pressure and the temperature of the gas? For a fixed mass of gas, the pressure of the gas increases as temperature of the gas increases. Assuming the change in volume of the conical flask is negligible when heated, observe what happens to the pressure of the gas as temperature increases. Click on the Start button to begin the simulation. The pressure-temperature graph is a straight line. This shows that the gas pressure increases uniformly with temperature. When the graph is extrapolated, it is found that the gas pressure becomes zero at negative 273 degrees Celsius. Theoretically, the temperature, negative 273 degrees Celsius, is the lowest possible temperature for a gas, at which all particles stop moving and there is no collision with the walls of the container, and thus gas pressure is zero. By shifting the vertical axis to the left and renumbering the temperature scale, negative 273 degrees Celsius becomes the zero on the new temperature scale. This temperature scale is known as the absolute or Kelvin scale of temperature. The Kelvin scale of temperature begins at absolute zero with a value 0 Kelvin. The graph now becomes a straight line passing through the origin. What is the relationship between the pressure and the absolute temperature of the gas? For a fixed mass of gas at constant volume, the pressure of the gas is directly proportional to its absolute temperature. That is, P is directly proportional to T, or P over T equals to constant. This is known as the pressure law. The formula can also be written as P1 over T1 equals to P2 .
Click and drag the slider to increase or decrease the temperature. From the graph, what can you say about the relationship between pressure and temperature?
For a fixed mass of gas at constant volume, the pressure of the gas is directly proportional to its absolute temperature. That is, P is directly proportional to T, or P over T equals to constant. This is known as the pressure law.